Welcome back. This is a section on filtering data on Kotlin collections. Okay, so filtering, what do we need filtering for? We want to typically filter the items in a collection of elements of data, and we get a brand new collection that contains only the elements that match our filtering criteria, otherwise known as a query. And think about it, in the modern world, we are software developers, we have access to databases, cloud databases, NoSQL. We want to get a subset of that data, and the way to do that is to have a query. Filtering is such a classic part of functional programming. The way it works is that we require a predicate. A predicate is simply a lambda function that matches against the element values in the collection. And so therefore a filter requires a lambda function that returns a Boolean result. Either it matched the criteria or it didn't, and it can have one or more arguments. So let's move on to the code. So in this pre-cooked example, I have again my numbers, and they are an integer range from 1 to 10. Okay, so let's say we want to get the even numbers out of these numbers. So we can have use the filter function, and then for each element x, we perform the modular of 2, and if it is 0, then we get the even numbers. Let's run this again. Also reference, of course, yes, I can use my placeholder, and therefore we can also get the odd numbers of, and we call that odd. The odds, and call that the odds as well. That's the trouble with cut and paste code. So therefore we are filtering for even numbers and then also filtering for odd numbers. This is a very simple filtering operation, and we get a list collection of integers, and we get back the subset list that matches this criteria. Okay, so that's good. Let's move on to the next thing. Okay, so in this example, I have some apparently random data. I have an old data list of integers, of numbers 5, 9, 2, 1, 4, 3, and I am filtering for numbers that only are greater than 2. So what can we do with this? So, for example, we can perform we can sort the numbers, and once we do that, we get the sorted numbers, and then we can reverse the numbers even. So as reversed, the numbers should go back to front for 9543 instead of 3459. The other thing we can do is that we can take the numbers, and after we sorted them, we can sum the numbers. We can actually also reverse the numbers as well, and we should get back the same answer. Doesn't matter if we add or we add them in reverse order or in order. Yes. But let's try something else. We can try a brand new function here to show you. I'm going to show you some aggregate methods, and then I'm using sum, but I can also sum and perform x goes to x. And what does that give us? That gives us the number 22, and we know that is the same as the placeholder it operator. So now it becomes quite useful to us. So we can perform even a square here. And if we do that, that means we are summing by the square of the numbers. So, okay, so this is really quite useful to us, because then we can also cube the numbers. I guess the interesting thing is when we look at some of the data operands. I'm just going to put this into temporary, so that we can actually see what the data types that come back. And this is interesting when you're working with filtered numbers, that we get the scalar value back. And so if I use just to see here, if I want to see what this temporary value is, this is all very helpful when you're working with mapped functions. You sometimes want to see what the type of the thing that is returned as an intermediate step, and using the scratch pad is really quite useful to see that we've got the temporary. So if we take away the sum by, we should have a list collection of ints as well. So that's all very useful stuff, really. So I'm going to move on to something much more useful. I'm showing you aggregation because we will use this later. Let's clear the decks. Okay, let's have a class. I have a class and I have some data from a database. So this data class is a regional sales class. It has the name of the director, which is a person, and the sales figures, say it's pounds or euros or dollars. So let's build a data structure. So this is my data structure. It is a geographic cells of a map collection of the region to the regional cells. Makes sense, doesn't it? So the UK health cells maps to regional cells of director is called Tom, and there's about 4 million whatever. The same with EU, it's mapped to a person called Vibka, a lady called Vibka. In the USA, it's mapped to another director called Barbara, and in Latin America, it's mapped to a fella called Javier. And so, as we see, we print out the regional cells. So, how could we negotiate this data structure? And so this is useful. So I guess I'm interested in. I want to find, say, my excellent directors, and I want to find the directors that have made, I guess, sales greater than £3 million or 3 million units. So I know that my entity is a region, and it's the area, and I have the geo cell here. So of course this is a map collection, and we know that, and I'm interested in I guess GL cells, or sorry, let's get it right. Regional cells, where the regional cells is greater than 3 million units. Okay, so now we're onto something now. So now we get back in a map of the collections of regions that have cells greater than 3 million. And we can print those excellent directors out like this. And now we can do a nice little thing where we can then perform a map, and where we're just again, we're taking the region and the regional cell here, and we just want to map the regional cell, regional cells to the director. And it would help if I could spell regional cells to the director. What does that give me? And you can clearly see that the top people who have sold more than 3 million units, pounds, are Tom and Barbara. And in fact, we do not need this intermediate step here. And this, because we're combining filter with a map, we can get direct to the result. So if I do some nice refactoring here, and then perform this map here. So let's try and get a little bit of order here, and I'll try to do that with the, you can see that directly we get Tom and Barbara, and this code does make sense, doesn't it? So it's it shows you functional programming, and this is eminently readable, so you can look at this code 6 months later. From my GL cells, I am filtering on the regional cells that are greater than 3 million, and I'm only interested in the director. This is filter function and then a map function, and we can go one better. Perhaps we want to know the actual total cells. So I could write something like this, where again I've got my geo cells. Well, I guess I'm going to call this the reg cells here, regional cells here. That's cool. Just to keep this on the same page. And I'm still interested in cells that are greater than 3 million. And it's at this time I'm mapping only to the sales figure. And from the sales figure, I'm performing a summation. So let me take that away. Let's run this just to show you that I am getting the value of total sales here. And total sales is 12 million. So this is because there's E7 here. In fact, I can turn this into an int, so that makes that even clearer. So yeah, it's yes, it's 12 million. Brilliant. So I want to show you, just I'll comment this bit out and comment this out temporarily, And when I do that, I get a list collection of the doubles here. And when I execute the total sales, you can see that I get the individual sales numbers, which are here and obviously here as well. And these two are aggregated together in a sum formation, and I get the total sales. So if I undo all of this now, we get to the result that we had before. Save, and then Scratchpad would do it, and my regional sales is that. Wonderful. And again, we can see from the code it's eminently readable. We're filtering on this regional sales here, this map collection or to regional sales. We're deriving, filtering only on sales greater than 3 million units. And then we are applying a map transformation. So we are only getting the actual sales figure here, this part of the data class. And then we get a list collection of the total sales. And then we sum, we reduce. And I'll come to that in the future lectures. Apart from that, that is all for filtering on Kotlin data collections. I hope you found this eminently useful, and see you at the next lecture.